In this class, we'll learn about the types of hashing. So there are two types of hashing. One is that open hashing, another is that closed hashing. Now we'll see that why we say that open hashing. Open hashing, it means that we have a given table size. We have a given table size, and if the collision occur, then what will we do? So if the collision occur, then suppose I have a zeroth index and there are two or more element is getting the zeroth index, what it will do? It will going to create the node outside the table size. It will create outside the table size, and there it is going to store the element. There it is going to store the element in the open hashing. And in the closed hashing, it will, what it will do? So suppose there is a table size, and if two or more element is getting the same index, it is going to store inside the table. It's going to store inside the table using the linear probing and quadratic probing and double hashing, and that's called, because of that reason it's called closed hashing. So right, so in open hashing type is separate chaining, and closed hashing type is linear probing, quadratic probing and double probing. Right, now coming to the what is separate chaining. Now we'll see that what is separate chaining. Separate chaining is most used collision hashing technique. So separate chaining is most used collision hashing technique, and that is using what data structure? Linked list. So separate chaining is using one data structure that's called linked list, and because of that reason only it's also called open hashing. And what it is saying that if two or more components that meet at the same point, it means that if two or more elements getting the same index are chained together form a singly linked list, right? So what it is doing that, if it is saying that if two or more elements, suppose here in the table 6 and 11 is getting same index is 1, are chained together, means what? It's forming a one singly linked list. Are chained together to form a singly linked list. Now what it is saying that every linked list member that has is chained to the same position. Yes, of course, if it is two element is getting the same index, that is going to form the singly linked list at that index. Right, then what it next is saying that the open hashing is used to avoid the hash collision using array of linked list. So what's the meaning of the array of linked list? Why it's saying that array of linked list? It means that if it is two or more element is also going to get that zero index, they are also going to form one singly linked list. If one index is getting that, here also forming one singly linked list. If third in 2, 7 and 12 is getting third index, so this is also forming one singly linked list. 3 and 13 getting this 5 index, so it's also forming the singly linked list. So it means that how many singly linked list you are getting, that means the table size, whatever the table size, that much single linked list possible to form. And because of that it's saying that array of singly linked list, because there are not a singly linked list you are forming, you are forming the array of singly linked list, and that size is what? Table size. So if my table size is 6, so how many singly linked list you can form? 6 singly linked list you can form. Okay, now we'll see that the example of separate chaining using division method. Suppose there is a question given, the array is given, array of element is given, and use division method. And one more thing, this is the method to calculate the index. Division method is nothing but it's just a method to calculate the index of given element, right? Next is saying that which collision resolution technique you apply to reduce the collision. So he is saying that use open hashing. So whenever the open hashing comes, what resolution technique will you apply? That is separate chaining. And if you are saying that separate chaining, then which data structure you are going to use? Linked list. So you are going to use linked list for open hashing. So here I have taken what? Here in question given that the table size, m is nothing but the table size is 10 and hash function is given 2k plus 3. Hash function is given 2k plus 3 and you are going to use the division method. So what will you do? 2k plus 3 mod table size. So that is your hash function. Right? So I have formed that table. It will going to help you to understand easy. That's why I have made that table here and I have kept that all these element as a key in my table. Right? So 3, 2, 9, 6, 11, 13, 7, 12. I have kept it in this column. Next I am going to calculate the location, and that too how you calculate the location or index, you can say that 2k plus 3 mod table size. So if I am going to calculate the index of the 3, so what will I do? 2k. So 2 into 3 plus 3 modulus table size is 10. So if I calculate this, I'll get the index is 9. So I'll go fast and check the table. Is my table free? So in starting, my hash table is completely empty. So this 3 is going to store at what index? That 9th index. So 3 is going to store at 9th index. Now coming to the second element, that is 2, and if we are going to calculate index of the 2 using division method of given hash function, then what will you do? 2k. 2 into k value is 2. So 2 into 2 plus 3, 4 plus 3, 7. 7 modulus 10, if you do that, you will get the index 7. So this 2, if you check that your hash table is free. So in starting, just now we have stored only 3. So that remaining part was empty. So that 2 is going to store at 7 index. Right? Then next came through the 9. Next element came 9. So if you are going to calculate index of the 9, 2 into 9 plus 3. 2 into 9 plus 3, then modulus if you do with table size, you will get that 1. Right? So again you check that table is free because just now we have only stored 3 and 2. So 9 is going to store at the first index. 9 is going to store at the first index. Right? Then what will you do? Then if the 6 come, you do with that same process you do and calculate the index. If you calculate index, you will get that 5. So far there is no collision occur. 3, 9 you are getting, 7 getting, 1 getting and 6 getting. Then again 6 is going to store at the 5th index. Now the another element came 11. Another element 11 came, and then what will you do? If you calculate the index, you will get the 5. And you have seen that recently you got that 6th element index is also 5 and 6 is already stored. So where this 11 is going to store, because 11 index is also coming 5. So do remember which hashing technique, which collision resolution technique you are using? Open hashing. So whenever the open hashing will come, what will you apply? Linked list. Which data structure will you apply? Linked list you apply. So what will you do? You have to create another separate node for the 11 and then store the 11. Now coming to the 13, if you calculate the index of the 13, you will get the index 9, and you see that the 9th index is already filled. So what will you do for the 13? Do remember open hashing, then create the one new node for 13 and then store the 13. Right? Then coming to the 7, if we calculate the index for the 7, 2 into 7 plus 3, a modulus 10 if you do, you will get the 7th index, and you have already seen that second element is, 2 element is already stored at the 7th index. That's already filled. So where will you store the 7? So what will you do? You have to create another node outside the hash table and you store the 7. Now 12 come. For the 12, also you are getting 7 index. Again collision occur. 2 is already stored. You have already stored the 7th element, one node. Again you create another node, and this n is nothing but this n is going to store the address of, suppose their address is 100 and the 12 address is, suppose this is the 200. This is the 200. So this none is nothing but it is going to store 200. This will going to store 200. It means that it's forming the singly linked list. So 2 is the 7th index is storing the address of the this 7th element, and this 7th element is storing the address of the 12th elements. So this is the separate chaining example. What it is doing, that you can see here, this is also a array of linked list. So here we have a less number of elements, so he formed that less number of the linked list, but the total possible number of linked list is that the table size, means there is a table size is 10. It means that we can form here total 10 singly linked list, right? Now we'll see the advantage of the separate chaining. What is the advantage? Because we have seen that it's open hashing. Every time it's creating the node, there is no fixed size. You can change the size at runtime. And anyway, the linked list is a dynamic data structure. You can change their size at runtime. And because of that reason, what it is saying, that it's easy and basic to implement. It's very easy to implement, because if it is your table size is 10, and if you are going to store 1000 element, that too also you can store. Why so? Because here there is no limitation of the size. Whenever you need some more element, then you simply create the one node and add it. Then another element comes, you can check that your table is completely filled, no problem, add it another table. Like that you can do that. So that's the reason it's very easy to implement, right? Then another is saying that as there are a lot of empty space, as there are a lot of empty space in the hash table, we can add more key to the tables, right? So same thing they are saying, that because space, there is no problem of space here, because you can simply create the node and you can store. Then is saying that comparatively less sensitive to different load factor, right? Another is saying that this will I'll explain in the next class if I explain about the rehashing, right? So for now it's just leave it. And another is saying that the mostly used when the unsure about the amount and frequency of the key. Yes. So when will you going to use separate chaining? If you don't know the number of key will come, because my table size is 10 and the number of elements, suppose we don't know, when 1000 come, 1 lakh come, and my table size is only 10. Will we do that with another hashing? That's not possible, because they are storing inside the hash table. But separate chaining is storing in outside the hash table, so there is no problem of this. So that's the thing, they are most preferable things. And coming to the disadvantage, of course the disadvantage here is that wastage of space. Suppose there are many element is getting same index, so you are going to store many element in the same index, means you are going to create the linked list, and remaining is completely free, right? So that time it's a waste of space. Okay, so why we am saying that waste of space? Suppose there is a 10 element come, and all this 10 element is getting only first index. All this 10 element are only getting the first index. So you got the one linked list with the size is 10, right? And remaining space is completely free. Remaining space is, this complete part is free only, because all these element is getting one index. So all linked list is going to form at 0th index, but your remaining space is still free, but you are making the linked list, right? So because of that reason is saying that waste of space, right? And it's also saying that with a long chain and the search time is increased. Okay, so in linked list one more thing is that it's searching the element linearly. So do remember, it's not an array and it's not the stack and it's not the key. Linked list is the linear data structure. So here if you are going to search an element, you have to linearly search. You can search one by one. First you have to search this 0th this index, then there you can search. So this is linearly searching. So this time will be, the time complexity of this search is order of n, and because of that reason is saying that the time complexity is high here. And poor cache performance as compared to close hashing. Yes, because of that reason only. That's all about the separate chaining. We have seen here how that open hashing, why we say that open hashing, and why we also said that the waste of space, that I have explained everything about the separate chaining. That's everything. Means what's the advantage, disadvantage. That's all about the separate chaining. Everything is this one only. There is nothing except this. Thank you so much for watching my video. If you like my video, do subscribe. So can I'll make some other video, other collision resolution tip. Thank you all.